discuss vectors again. We're going to be specifically talking about vector equation today. So from O levels, you know equation of the straight line in 2 dimensions. This is y-axis and this is the x-axis. And if you have 2 points on this plane, you know how to find equation of the line connecting the 2 points. That equation would be in the form y equals mx plus c. Now, in A levels, we are in 3-dimensional plane. Not sure how I will plot this x, y, and z. Now, if you have 2 points on this plane, each coordinate, there will be an x and y and z coordinate for each point. Now, if you find vector equation of this point, you will be using this equation. R equals a plus tb. Or another equation, if you remember from O levels, इसको हम इस तरह भी कर लेते थे, point slope form इसको कहते थे, y minus y1 is equals to mx minus x. So similarly here you'll have r equals a plus t times b minus a. अब r is like y, r ही रहता है. So you write r equals, what is this a? A is another known point on this line, on this vector line. Okay, so A is another known point on the vector line. So let's write a position vector, a known position vector on the vector line. A known position vector on the vector line. अब position vector मैंने क्यों बोला है? If this is a known point, let's say it has coordinates 1, 2, 3, then your A is going to be 1, 2, 3. You'll actually be stating the position vector from O to A. Okay? So that's why I wrote a known position vector, because we write it as a column vector and not as a point. So a known position vector on the vector line. Okay. Now, what is this B? This B is a vector parallel to the vector line. A vector parallel to the vector line. So, if you know another vector passing through here, which is parallel to the original vector, तो वो आप B की जगह substitute कर दो. Okay, let me give you an example question from this form first. So, find the vector equation passing through (1, 2, 3) and parallel to 3 minus 1, 4. So who can tell me what's going to be our vector equation in this case? एक पॉइंट पता है ऑन द वेक्टर और एक और वेक्टर पता है जो उस वेक्टर के पैरेलल. So how do we find the vector equation in this case? I'm assuming you guys know and are just being shy. R equals, instead of A, I'm going to write 1, 2, 3, a known position vector on the vector line, plus T times B should be another vector that is parallel to that vector line. So that's 3 minus 1/4. Achha, in some books, T is replaced by mu. So you might find mu in the marking scheme, or you might find, best marking scheme, it's usually mu. But you can use any variable you like. And especially if there are two vector equations, एक में mu आ जाता है इधर और एक में lambda आ जाता है. So I think I'll also stick to mu and lambda. But I think in the book, it's mostly T. Although it does not make any difference what variable you're using to represent that. Okay. So this is going to be R is equals to 1, 2, 3 plus mu times 3 minus 1, 4. Any questions here? Do I need to give you more example questions like this? Yeah, should we move on to the second equation? This one. बताएं. एक और एग्जाम्पल कराऊं ऐसे या समझ आ गया ये कॉन्सेप्ट?
मैम आर भी पोजीशन वेक्टर है.
हाँ
मैम आर भी पोजीशन वेक्टर है. आर
हाँ आर भी पोजीशन वेक्टर है बिल्कुल. आर इज ऑल्सो पोजीशन वेक्टर. ठीक है. आर स्टेज आर एंड टी और म्यू स्टेज टी. बाकी आपको ए और बी की वैल्यू पता चाहिए. एग्जैक्टली आई शुड हैव मेंशन्ड दैट आर इज ऑल्सो पोजीशन वेक्टर. Okay, now let's take a look at this equation. R equals A plus T, B minus A. Now the B is not the same B as before. This B is not a vector parallel to the vector line. Up, A is the same thing. Okay, then now A and B are two known points on the vector line, or two known position vectors on the vector line. एक ही बात है. Or two known position vectors on the vector line. So now, on the vector line, you'll have two known points. Let me say, here's the vector line whose equation we're trying to find, and you'll know 2 points here. Let's say this is 1, 2, 3, and let's say this is 4, 5, 6. So it's going to be R equals, A can be any one of these. For example, A is 1, 2, 3 plus T or plus mu or plus lambda. Let's use lambda now. Times B minus A. Remember to use the other known point now. So that's going to be 4, 5, 6 minus 1, 2, 3. So that would be R equals 1, 2, 3 plus lambda 3, sorry, 5. No, subtract here, sorry. 3, 3, and 3. Okay, so this is the vector equation. Had you taken B here, तो फिर आप यहाँ पहले लिखते A और फिर b से माइनस करें। It depend which point you're taking first. लेमडा के साथ पहले दूसरा पॉइंट आता है, फिर माइनस फर्स्ट। So another answer to this could be R equals, I'm writing the other one first, 4, 5, 6 plus lambda ki jagah I'm going to write mu, and then use the other one first, 1, 2, 3 minus 4, 5, 6. So R equals 4, 5, 6 plus mu and minus 3, again minus 3 and again minus 3. Both of these are correct answers. Marking C में दोनों लिखे होते हैं, this or this. So that's how you find a vector equation using any of the two methods. Depends आपको क्या given होता है. अगर आपको एक parallel vector given होगा, so you'll use this equation. But if you're given 2 points on the vector line, then you use this equation. So it depends on the scenario. Okay, moving on. अच्छा, another thing, another very, very, very important thing. जो आंसर लिखा होता है ना मार्किंग स्कीम में, वो इस तरह से नहीं लिखा होता कॉलम वेक्टर्स में. If there's even a slight mention of ijk in the question, this is the kind of answer that is expected from you. You have to write 1i or just I plus 2j plus 3k plus mu bracket 3i minus j plus 4k. This is what will get you the final A1 marks, not this one. You can do all your working in the column vector format if you're more comfortable with that. However, remember to convert your final answer into IJK form. हर वेक्टर के क्वेश्चन में हमने कोशिश करना है कि हमने अपना फाइनल आंसर IJK के फॉर्म में, क्योंकि कुछ मार्किंग स्कीम में they sometimes very rarely mention this as well, or with that they mention this as well, but in many marking scheme they only mention IJK format and not the other format. So you never know if they will give you full marks for this, because it clearly says the final statement and then A1. So if that final statement is not there, A1 cannot be given. Okay. Achha, now so far we've learned how to form a vector equation. Now we're moving on to the second subtopic, which is finding if a point lies on the vector line or not. Find if given point lies on vector line or not. You've done similar questions in 2D. आपसे पूछते थे कि ये इक्वेशन ऑफ स्ट्रेट लाइन है, तो ये पॉइंट इस पे लाई करता है या नहीं. What did we do in O levels? You have an equation of a line, let's say point A है, ये point B है. You have an equation of a line y equals 3x plus 1. And you're asked to check whether this point 1, 2 lies on this line or not. तो क्या करते थे? Y की जगह 2 substitute कर दिया, x की जगह 1 substitute कर दिया. We get 2 is equals to 4, which is not true. Hence that point 1, 4 lies somewhere else, not on the line. So we'll do something on the same lines here as well. So now you have a vector line. Let me do an example with you to explain this question. Okay, so the question is, find whether this was given. Okay, find if -3, 1, 5 lies on the line R equals 131 plus mu minus 2 minus 1, 2. Find whether minus 315 lies on 31 mu minus 2 minus 1, 2. So how do you check that? You replace this position vector with this position vector. So write that in the form of position vector minus 315 equals 131 plus mu minus 2, 1 minus 2. Actually, there's a minus 1 with 1 and not with 2. Okay. So now how do we tell if that lies on the vector line? You have three equations here. Minus 3 equals 1 minus 2 mu, equation 1. And then 1 equals 3 minus mu, equation 2. And then 5 equals 1 plus 2 mu, equation 3. If all mu's give you, if all three equations give you the same answer for mu, that means that yes, that point does lie on the vector line. But if you're getting, let's say, two of the mu's are same, but the third mu is different, that means it does not lie on that vector line, because mu is supposed to be a constant. Like m gradient hota tha, m ki value to for a particular line, it's going to stay the same. It cannot have different values for the same line. So similarly, mu should have the same answer for all these equations. Is that true? Are we getting the same mu's for all three equations? Please check and tell me. What's the mu for part 1? What's the mu for part 2? And what's the mu for part 3?
मैम सेम आ रही
Same आ रहा है, क्या आ रहा है?
2
2. So you get mu is equals to 2 for all three of them. Mu equals to 2, mu equals to 2, and mu equals to 2. Since mu equals to 2 for each case, hence minus 315 lies on the vector line. You must write a concluding statement because it is mentioned in the marking scheme. Conclude karna zaruri hota hai. Okay. Another question like this, I'm going to change the coordinates. I'm just going to change the line. So the vector equation is now different. It is 0, 1, 2 here. 1, 0, 3 here. And I'm changing mu to lambda. So now again, you will first substitute minus 3, 1, 5 here. Copy the same right hand side, 0, 1, 2 plus lambda 1, 0, 3. Form three equations and tell me if we're getting the same value of lambda in each case. I'm going to send you a new link. Till then you solve this. I'm going to send you a new link now. Are we getting the same value of lambda in all three equations?
डिफरेंट आ रही है मैम ये
First one is lambda equals minus 3. And the last one is lambda equals 1. And in the second one, lambda is getting eliminated and we're just getting 1 equals to 1. So hence, since there is not a fixed value for the constant lambda, hence minus 315 does not lie on the given vector line. Since there is not, since we don't get ज़्यादा बेहतर English लिख दो मेरे से, since there is not one fixed value of lambda, fixed value of the constant lambda, hence given point does not lie on the given equation, vector equation. Stylist जवाब देंगे. Given point does not lie on the given equation. What's next? So we learned how to tell if point lies on a given vector equation or not. Let's move forward now. We're going to learn how to tell if given points are collinear or not. So the next subtopic is find if given points, what's wrong with the screen? If given points are collinear or not. So we've discussed collinear points a couple of times. Collinear points are points lying on the same straight line. And if we are in 3 dimension, we're going to say that the 3 points should lie on the same vector equation. So this is what you have to do. You'll be given 3 points. आप पहले उससे वेक्टर इक्वेशन बना लोगे यूजिंग 2 पॉइंट्स और फिर थर्ड पॉइंट को r की जगह सब्स्टिट्यूट करके you're going to see if you're getting the same value for mu or not. Okay, so how this is different from the previous question we just did. Here you don't have a vector equation. So what you'll do, you'll use these 2 points to form a vector equation using this formula r is equals to a plus mu b minus a, because now we have 2 points on the vector equation. So we're going to use this formula. So once you get this vector equation, you're going to substitute this here and see if we're getting the same value of mu for all 3 equations or not. If yes, then yes, the 3 points are collinear. That means they lie on the same vector equation. And otherwise, the answer is no. Okay. So the question is, determine whether each of the following sets of points are collinear or not. Determine if each set of points are collinear. Linear में शायद double L है, I'm not sure. Collinear or not. Okay. So in part A, we have 3 points 1, 2, minus 1, 2, 4, minus 3, and 4, 8, minus 7. 1, 2, minus 1, 2, 4, minus 3, and 4, 8, minus. Okay. So what we'll do first, we'll form a vector equation using these two. So R equals A plus mu B minus A. So 2, 4, minus 3, minus 1, 2, minus 1. So that's going to be 1, 2, minus 1 plus mu 1, 2, minus 2. 1, 2, and minus 2. Okay. So that is going to be the vector line passing through points A and B. Now we're going to check if C lies on this vector line or not. So for that, we're going to substitute the value of C, 4, 8, minus 7 equals 1, 2, minus 1 plus mu 1, 2, minus 2. Form three equations. 4 equals 1 plus mu. 8 equals 2 plus 2 mu. Minus 7 equals minus 1 minus 2 mu. Are we getting same value of mu for each case? For the first one, we're getting mu equals 3. For the second one, we're getting mu equals 3 again. For the third one, we're getting mu equals to 3. So yes, the three given points are collinear. Since we get same value of mu for all three equations, hence the 3 points are collinear. Please write the concluding statement. Since we're getting a constant value of mu, hence the 3 points lie on the same vector equation. Okay. Now I'm going to ask you to do part B on your own independently. I'm going to give you the 3 points. 5, 2, minus 2. 5, 2, minus 3. Minus 1, 6, minus 11. 3, minus 2. क्लास हो रही है, बोले क्लास के बाद कॉल करते हैं। बाय लेजर। 5, 2, minus 3, minus 1, 6, minus 11, 3, minus 2, 4. Okay, do this on your own. So how do we proceed with this question? Form a vector equation using AB. Now you can also form a vector equation using BC or AC. So the answers will vary for the case you choose. So if I've used an AB and in AB I've written A first and then B minus A. So if you've done that, you should get these 3 values of lambda. Again, if you're using a different set of coordinates, 2 coordinates to get the equation, or even if you swap the order in which you've taken the coordinates, you will get another set of lambdas. So in the marking scheme, there are like 5, 6, 3 cases of lambda given to you. One of these would be this. Like in the marking scheme, you'll get answer like this. This or this or this or this. So you'll get multiple scenarios. One of these would be this, that lambda equals 1 by 3, lambda equals minus 1, and lambda equals minus 7 by 8. So the bottom line is that no, the 3 points are not collinear, since we are not getting a constant value of lambda that satisfies the vector equation. All right, that's all for today. I'll see you next time.